Yo, AP Stats, look what I figured out. My webcam, yay! So even though I'm not there with you, you can at least see me. And as I'm walking through it, so that the video is a little less boring. So yeah, I'll be able to keep some of you like Melvin awake. Uh, Maybe Nikita. Sorry, Nikita. I always pick on you. Um, but yeah, anyways, I was just I just wanted you to review a question real quick before we get started on what we're going to do today. So, right now, I want you to take a look at this problem. And based on what we did yesterday, I want you to calculate and interpret the expected value of x in this situation. So, maybe pause the video at this point and take however long it takes you to do this calculation. Okay, hopefully you have an answer at this point. Um, so hopefully you were able to get that the expected value was an APGAR score of 8.128. And what this means is if many, many, many newborns were randomly selected, the average score of all of them would be about 8.128. All right, so our topic for today is going to be we're going to talk about the standard deviation of discrete random variables, what it means, where we get it from, and we're going to talk about continuous random variables. And that'll be it for today. Um, I believe that actually teaching this way is a little bit more efficient because there is not a lot of me kind of wasting time, even though I'm sort of wasting time right now. But it's also bad because then you can't really ask questions and I can't really read where you are at. But I do hope that this could be efficient and that you would use the rest of your class time to either read the book and or do homework questions. So if you haven't already figured it out from Google Classroom, you do need to bring your books each and every day that I am not here. Okay, so back into our lesson. Um, So when we are looking at our mean as our measure of center, um, hopefully you've learned from chapter 2 that your measure for spread is going to be standard deviation. Remember that if you're using median, your measure for as your measure of center, then your IQR and your range are your measures of spread. And because we are using mean, which is our expected value, then our standard deviation is our standard measurement for spread. So in general, the the measure for standard deviation in terms of the AP exam, it doesn't pop up that much. But I've seen it tested, and I still think it's kind of important for us to at least go over it. Okay. And it shouldn't surprise you because we're gonna, just like with everything else, we're gonna start by subtracting our values from the mean and then squaring it. Okay. This is to deal with negative numbers, right? Because if if we had negative numbers and we multiplied by the probability, and then we had positive numbers multiplied by the probability, it's going to end up with 0. So since we want kind of like the distance from the mean, then we have to square it and then multiply by the probability and then take the square root. right? So each of our values is, we take each of our values, subtract by the mean. In case you were wondering what this is the expected value of x. Okay, so this is the mean value. That's your expected value. Okay, so you take x1 minus the expected value of x, and then you square it, and then you multiply by its probability. Then you take the x2 minus the mean value of x squared times the second probability. Then you take x3 minus the mean value of x multiplied by the third probability, so on and so forth. Then you square them all, and then you take the square root. So if you were doing it for this APGAR score, you can see this is how you would do it. Okay, it's the same type of calculation, right? You take the value of 0, subtract by the expected value, square it, and then multiply by its probability on down the line. Okay, I think I was supposed to have you calculate it, but this is a very long calculation, so you can kind of use this as an example and then use your book to kind of practice this. Okay, so we're going to continue by talking about continuous random variables. continue, never mind. It's not funny. So we're going to talk about continuous random variables, and how they're different than discrete random variables. The biggest difference, and I kind of touched on it yesterday when I was talking about discrete random variables, the main difference is that continuous random variables can take on any value within an interval on the number line. And so an example of this is I guess this uniform distribution. Like, the best way to sum it up is that if I were to randomly generate a number between 3 and 7, if it's not an integer, it literally can be an infinite number of possibilities, right? It could be, you know, 3, it could be 3.01, it could be 3.002, it could be 3.14159, it could be like 5.14, it could be anything within this region, okay, any number. So let's say, let's give like an example. Let's say Selena works at a bookstore in the Denver International Airport. She takes the airport train from the main terminal to get to work each day. The airport just opened a new walkway that would allow Selena to get from the main terminal to the bookstore in 4 minutes. She wonders if it would be faster to walk or take the train to work. Let y equal Selena's journey time to work in minutes by train on a randomly selected day. The probability distribution of y can be modeled by the uniform density curve on the interval from 2 to 5 minutes. Find the probability it'll be quicker for Selena to take the train than to walk that day. Okay, so if you were to look at this, right, and you were to draw her distribution, so if you were to look, right, it's from, the curve is from 2 to 5 minutes, right? What's the probability that it'll be quicker for Selena to take the train than to walk in that day. Well, if you look at it, right, you just take the shaded area, um, which is right here, right, between 2 to 4 minutes. And then the height has to be 1/3 because the area under the curve needs to be 1. And then you just take what? 2 times 1/3, which is 2/3. So the probability that it'll take Selena less than 4 minutes is around 2/3 or 66%. So there is a 66.7% chance that it'll be quicker for Selena to take the train to work on a randomly selected day. Okay, now if I were to continue with this distribution, generally heights of people are modeled by normal distributions. So if we were looking at the heights of young women with a mean of 64 inches and a standard deviation of 2.7 inches, and we chose a young woman at random and let her height be y, let's find the probability that that woman is between 68 and 70 inches. Well, if we were to do it, let's say ignore the table A, okay? If we were to use it using like technology, right? Actually, even this is not right. I would use this one right here, okay? Is if I did normal CDF with a lower bound of 68 and an upper bound of 70, and then a mean of 64 and a standard deviation of 2.7, I would get that there is a 5.6 probability of me, like, 5.6% or 0.0561 probability of me selecting a woman between the heights of 68 and 70 inches. Okay. And that's it. Sorry I rushed through the end, but I think my time is up on the recording. Wasn't up yet. But anyways, bye. Start working on problems, please.